Welcome back to Elements of Chemistry. Today we're going to talk about doing math with significant figures. This is how we avoid having to ask, where do we want to round the number or report an answer in a science class? You always use significant figures. Anytime you're dealing with math and a measurement, we round the correct number as sig figs. So the number that appears on your calculator screen, yes, it is mathematically correct, but it's not significant. When you start multiplying uncertain digits, you start multiplying your errors in estimation. So there's certain rules that a science student needs to follow. First, for addition or subtraction, no more decimal places in your answer than the least of your given. So if you were asked to add 4.5 centimeters plus 5.678 centimeters plus 67.1 centimeters plus 55.234 centimeters, you're getting the perimeter of an air of some shape. Okay, can you really use your ruler to the thousandths place, or are you being a little over generous with your estimation on that last place? We don't know. We don't know how fine your ruler was. But what you do is like you did when you were first learning how to do math. You'd write your numbers down. So here we've got 4.5. And when you first learned how to add decimals, your teacher probably told you to line up the decimal points. And our last one here, 55.234. And we're going to add these. So you would add like normal, and we're not in elementary school math, so we're just going to do this real quick on a calculator. And we get the answer. And these are all centimeters we're adding, so we're going to put our centimeters in. Okay, well, we're not real certain about that many places. So we use what's called the chop-off rule. And how the chop-off rule works is you chop it up off at the least number of decimal places. 4.5 has 1, 5.678 has 3 decimals. So we're going to come in, oops, I lost my line a little bit there, and chop this number off at 1 decimal place. Then for rounding, we're going to look to the right. That digit there is a 1, so we're going to leave it alone, and we're going to report our answer as 132.5 centimeters. So adding, subtracting, chop off rule. And remember, always look one place to the right to round your answers. Okay, the one we're going to use most often, especially in chemistry, is multiplying and dividing. You look at the total number of significant figures in each number you're working with and round your answer to the least of the givens. And that's a key. Conversion factors and constants are unlimited in their sig figs. So when you're doing your dimensional analysis and you've got it on your track, you're only looking at the digits in that very first measurement that you're converting. If it's got 3 significant figures, your answer better have 3 significant figures. All of these other values that we're putting in here, those are all conversion factors or constants, and they never change. They're unlimited in their number of sig figs. So multiplying and dividing, no more digits in your answer than the least of your givens, your measurements. So let's do this one here. We're multiplying. I've got 2.3 times 2.45, 2 significant figures, 3 significant figures. I know my answer has to be 2 significant figures, and it has to have units of meters squared because I have a meter times a meter. On a multiple choice type test, that's all you really need to know, because quite often it's the significant figures that make the difference. But if we took 2.3 times 2.45, we would get an answer of 5.635. Well, I have to round that to 2 figures. So I'm going to look to the right. That 3 is going to leave the 6 alone. So 5.6 square meters would be the answer that I would put in my box. I always have my students box their answers because the box kind of stands out. It's like for the teacher, grade me, this is what I want my answer to be. It's not my work. So let's try some of these together. Here we've got a subtraction. Now, the decimal point lies normally here. So you go where the inferred decimal would be. So we've got 125 minus 10. That's going to give me 115 degrees Celsius. We chopped it off, and there were no decimals, no decimals. Okay, on this next one, we're doing a subtraction again. So we have 4.25. That's a 2. 2 doesn't look like a 2. Let's start again. Sometimes my Apple Pencil doesn't really. There we go. Minus 0.022. Well, we're addition subtraction. We're going to have to chop this one off. So I'm going to have to chop this off at 2 decimal places. My answer that I got was 4.228. I look to the right, so that's going to be 4.23. Okay, here's one in scientific notation. And if you notice, we are multiplying here. So we do this on our calculator, 1.2 times 10 to the fourth times 2.354 times 10 to the second. And remember, you might need to add those parentheses depending on what calculator you have. So this gives me a really big number. Because it expanded it out. I have 2 significant figures, 4 significant figures. I can only have 2 significant figures in my answer. Start at the big end of the number, 1, 2, look to the right. That 2 is not going to affect the 8. So the rest of this number, effectively, those become zeros. Or 2.8 times 10 to the 6th power. I tend to like to put these in scientific notation because the number of sig figs just jumps out at you. So now it's your turn. Let's try a few of these and see how you do. Go ahead, pause the video, and then come back when you're done. Okay, hopefully you've had some time to do those. Once again, we're going to be doing adding and subtracting chop off rule. So the rule is we're going to line them up. So 23.76 minus 21.1. We're going to chop it off at the tenths place. That's going to give me 2.66, which when we round gives me 2.7 milliliters. Make sure we carry that unit through. Here we have 1,000 plus 0.0025. Well, that 0.250 is very insignificant compared to that 1,000. So 1,000 has its decimal right here. 0.25, we're going to cut it off at the least number of decimal places, which would be right there at the decimal point. Since that's a 2, we're not going to round up, so our rounded answer is still going to be 1,000 milliliters. Here's a temperature one. We haven't talked about temperature conversions yet. That's in a future video. So we've got 100.0, 4 significant figures, minus 35.4. Well, we're going to chop it off at the tenths place, just like it looks. So 100 minus 35.4. This is going to give me 64.6, and there's no need to change anything. It's already right there. Okay, here's one working with our dimensional analysis. So let's practice that. We're going to set up our ratio, our given 345 feet. We know that there's 12 inches to 1 foot. Foot and feet, just plural, they cancel each other out. So boom, boom, that cancels. 345 times 12 That's going to give me 4140 inches. I go to my given, three significant figures. 1, 2, 3, look to the right. It's already in the correct number of significant figures. So that one was just kind of serendipity. We can box it to say that's the answer we want. Here we're going to convert 13.1 pens, not penning, 13.1 miles to kilometers. I'm going to use the train track method here. There's 1.609 kilometers for every 1 mile. The miles are going to cross cancel. 13.1 times 1.609. That's going to give me mathematically correct 21.0779 kilometers. Well, that's kind of crazy. It's mathematically correct, but not significant. So we go back to our given. That has 3 sig figs. So I need to round this answer to 3 sig figs. So it's going to be 1, 2, 3, look to the right. That 7 is going to make the 0 go up to a 1, so 21.1 kilometers is our answer. I hope this helped with doing some math with significant figures. Remember, you always use significant figures to know where to round an answer in chemistry class. Some notes to remind you. There's a special rule for dealing with significant figures and logarithms, but we're going to address that later in the acid-base unit when we study pH. So if you're looking for that, it'll be out in a few weeks probably. Okay, so have a great day. As always, stay curious, be kind, and be safe out there. Have a wonderful day.